Hello everyone, this is the first lesson recording for IM2, September 29th, 2020. The warm-ups we started off with was recognizing triangle congruence review. So please go to this link if you have not done so. You're working on card 1 to 11 for now. Few announcements. Quiz 2 is going to be next class. It's going to be on rigid transformation rules and triangle congruence. So make sure that you go back to the homework and make sure that you are very comfortable with them, and also do your homework. Another thing, there is a homework for today, and that's actually due next week. However, there will be more homework that was given out on Thursday. Okay, so I suggest that you try to do the homework today, and I promise I won't give too much homework on Friday or Thursday, but you need to check. Okay, so on Thursday, that will be Thursday, October 1st, 20, independent work A, independent work B. This is in lieu of the class meeting on Thursday. There will also be Unit 1 and Unit 2 test answers available on Thursday, as well as instructions for test corrections. So if you're interested in raising your test grade, and I hope a lot of you are thinking that if you got under 80%, you can get some credit up to 80%. What are we doing today? We're going to recognize more complex congruent triangles and use congruent triangles. So what do we know so far? We know the triangle ABC is congruent to a triangle LMN. If we know this, then we know that angle A and angle M are congruent, angle C and angle N are congruent, and angle B and angle M are congruent. Similarly, we know that side AB has the same measure as side LM, and side BC of the triangle has the same measure as side MN, or they are both congruent, or in side AC of the triangle are congruent to side LN, so that means they have the same measure. Triangle congruence theorem so far, we said that there were 3-letter acronyms combination possible were SSS, SAS, SSA, and ASA, AAS, and SAAA and AAA. And of these, we said that SASA and ASS and AAS and SAA, they are same thing. They are same thing to each other, right? They're just looking at a reverse directions. So we just need to look at it one direction. And we also said that AAA is not a congruence theorem. And we also discovered that ASS, or the donkey theorem, or SSA is not a congruence theorem. And it's easy to remember this by saying, this is a bad word, we're not allowed to say it in math class, so this is not a congruence theorem. Okay, but otherwise we know that SSS is a congruence theorem, SAS is a congruence theorem, ASA is a congruence theorem, and whether it's AAS or AAS, they're congruence theorem. Okay, what this basically means is that when you have two angles, when you know the two angles and a third side, then it's always going to be congruent. So two angles and a side, whether in any combination, it's going to be congruent. Okay, because we can actually figure out the third side even if it's not in the same order by doing the triangle sum, right? All right, so right now you are going to go to Desmos activity and do provide counterexample. What does counterexample mean? It's you're basically drawing a picture where precondition is satisfied. Okay, so you're trying to draw two triangles where they both do have congruent angles. Okay, so three angles are the same in a triangle. So you're drawing two different triangles with same angle measure, but you can obviously tell from looking at it they are two different triangles. Okay, so I want you to do card number 11 and card number 12. Card number 12 deals with ASS, why that is not a triangle congruence. Okay, so it's just asking you to explain, do you really understand this? Okay, I'm going to assume that you have done it. So counterexample for AAA would be something that looks like this. You can tell that this angle and this angle, they are congruent. This angle and this angle, they look like they are congruent and they are marked as being congruent. And then the third one, third angle, they look like they're congruent and they are marked as congruent. But obviously, are these two triangles congruent? Well, no, this is a much smaller version of this one. Okay, so if I map this small triangle on top of this bigger triangle, am I going to match up exactly? No, the two vertices are not going to match up, so they are not congruent. So this will be a counterexample where AAA fails, and that is the reason that AAA is not a congruence theorem. What about ASS? Well, you can tell that you have an angle, side, side here. Okay, so you have angle and side here, angle and side, they are same. And the third side, they are same in measure, however, they're oriented differently. One is pointing towards that angle here, one is pointing away. And when you've basically created two different triangles, two different looking triangles, they have the same angle, side, side measure. Okay, angle, side, side measure, but obviously they are not congruent. So this is an example of where it fails. Okay, I'm going to give you another example of ASS. That's a counterexample. That's, in my mind, a little simpler. Let's see if you can understand this. Okay, so if I drew a isosceles triangle, okay, so I am told that this side length and this side length, they are the same in measure or they're congruent. That means the angle that's opposite this angle and the angle opposite to the congruent side, the two base angles are congruent. Okay, that's the isosceles base angle theorem, right? Now, if I was to draw from the tip, but this time I am going to draw down at an angle, some angle, it's not going to go straight down at a perpendicular, but at some angle, okay? I know that from looking at the triangle that is formed on the left and triangle that is formed on the right, okay? I have created two different triangles, but they have the same shared side, right? So I've just created two different triangles, and I can sort of even shade this. My green triangle looks like this, and my yellow triangle, let's just do pink. My pink triangle looks like this, okay? But if I was to look at what features I do have, I have the angle that is congruent as indicated by the notch here. Angle is congruent, and then we have another side being congruent, and then we have a third side being congruent between these two triangles. So we have angle, side, side congruence, angle, side, side congruence. So in theory, we have angle, side, side congruence between the green triangle and the pink triangle. But does the green triangle and the pink triangle look the same? Not at all, right? One is way skinny, the other one is this one is a obtuse triangle, and this is an acute triangle because all the angles are made by acute angles. So obviously, ASS fails here. But here's a monkey wrench. Okay, so we just said that ASS does not work, okay, as a congruence theorem. But there is a special case of ASS where it does establish congruence, and that is when you have ASS, so we have angle, side, side, and angle, side, side, and the angle we're talking about is a right angle. Then the remaining side must be congruent. How do we know that? So the third side that we do not know. So we don't know the third side here. We do not know the third side here. But we can use Pythagorean theorem that says leg 1, that's one of the leg, plus squared plus leg 2 squared is equal to hypotenuse squared. That's the Pythagorean theorem that you should have learned from last year. So the two triangles must be congruent because the third side, they're congruent to each other. If you have one side is congruent, the hypotenuse and hypotenuse is triangle is congruent, then the other leg has to be congruent too. And this is called the hypotenuse leg theorem, or in some textbook it's going to be called right angle hypotenuse side theorem, or sometimes I learned it as right hypotenuse side. So right, it looks like right hand side, that's how I remembered it when I was growing up, right hand side, but it actually stands for right angle hypotenuse and side. Again, really important for HL to work, we have to be dealing with right angle. Okay, so I want you to send me a private chat as to whether you think this is a congruent triangle, these two triangles are congruent or not. Okay, all right, I'm assuming you had a chance to think. So what do we have so far here? We have side 6 centimeters, and then we have another side, and then we have the angle 35 and 35 here. Okay, so what do we know? What do we have? Well, it depends on which direction you are looking at. This is angle, this is side, we're talking about another, and side, and we're talking about angle, side, and side. Depending on which direction you're looking at, you could see it as side, we don't have an angle here, side, and then finally an angle. Okay, so side, side, angle, we have side, side, angle. Or if I was to look at a different direction, you would have angle, and then you have a side. We don't have an angle here, so it's angle, side, and then side, angle, side, side. Okay, and likewise we have the same thing here. But what do we say angle, side, 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 or side, side, angle is? It is not a triangle congruence. So no, these triangles are not congruent. Okay, what about this one? Can you pause the video and see if these two triangles are congruent? And if you know they are, tell me by what? How do you know that? What is the congruence theorem that you're using? Okay, again, I'm going to assume that you've had a chance to look at this, pause this. And what do we have? We have a side here, and we have a side here. And we have another side here, and another side here, and we have an angle and an angle. Okay, so in theory we have angle, side, side, and we said the angle, side, side is not a triangle congruence, except when the angle is a right angle. In that case, we actually know this is not just the side, this is the leg of a right angle triangle, and this is not just a normal side, but this is a hypotenuse. So we have HL congruence. Okay, so these two triangles are congruent. Yes, by HL. What about this? Please pause the video and see if you can tell me whether they are congruent or not, and tell me by what they are, by which theorem. Okay, I'm going to assume you have done that. So what do we have? We have a side that is being congruent and another side that is congruent to each other. We have a different side with two notches, tells me that you have two different sides that are congruent, and then finally you have an angle. Okay, which happens to be right angle. Okay, however, do we have hypotenuse leg? Hypotenuse leg. Hypotenuse leg, this is hypotenuse. This is the hypotenuse. Are we given any information about hypotenuse here or hypotenuse here? No, we don't. Okay, but we are given two legs or two sides adjacent to the angle. So this is actually, yes, they are congruent by SAS. SAS. Remember, we have to go in the same direction. Okay, and this, the previous one, just so that you know, it is not by HL. Okay? All right, so I'm going to stop right there and continue in the next lesson recording.